All right, let's get right into it. You've probably heard the terms firmware and embedded software tossed around, maybe even used them interchangeably. I mean, it makes sense, right? They both live deep inside our devices, kind of running the show behind the curtain. But here's the thing, they are not the same at all, and that difference, it's absolutely critical. So, what is the real difference? And more importantly, why should you care? Well, that's exactly what we're going to break down right now. And trust me, by the end of this, you're going to see all your smart gadgets in a totally new light. And when I say every device, I mean every device. We're talking about the code that brings your smart thermostat to life, that makes your washing machine run its cycles, the super complex control units in your car, even massive industrial machines. This isn't just some abstract tech topic. It's literally the invisible engine that powers our modern world. Okay, let's start at the very, very bottom of the software stack. Before a device can do, well, anything, its physical hardware, the chips and circuits, needs to learn how to exist. And that's where firmware comes into the picture. You can think of firmware as the most basic, most fundamental set of instructions you can get. It's what we call low-level code, which just means it speaks directly to the silicon. It's the essential translator that bridges that gap between the raw, physical hardware and any other software that wants to run on it. So, firmware has a few really key jobs. It's what handles booting up the device, that very first spark of life when you press the power button. It's stored in what's called non-volatile memory, like ROM or flash memory. All that means is the code stays there, even if you unplug the device. And that's actually where it gets its name. It's called firmware because it's firmly attached to the hardware, almost like it's a part of it. And because it's so fundamental, updating it is rare and kind of risky. Here's a great way to think about it. If a device were a living thing, firmware would be its brainstem. It handles all the involuntary, essential functions that you don't think about, like the power-on sequence or making sure the basic hardware is working. It's not doing any complex thinking. It's just making the hardware work. Okay, so now let's move up one layer and see how this all builds. Once the firmware has woken the hardware up and made it functional, that hardware needs a purpose. It needs a mission, and that is the job of embedded software. Embedded software is the code you, as a user, actually experience, even if you don't see it directly. It's written for that very specific piece of hardware to let it perform its dedicated job, over and over again. It runs on top of the solid foundation that the firmware has already built. Now, embedded software is super specialized. The software in your smart thermostat is only designed to do one thing: control the temperature. It's not going to let you browse the web. And it has to operate within some really tight constraints. We're talking limited memory and limited processing power, so it has to be crazy efficient. It handles all the complex stuff like processing data or dealing with your button presses, and this is where you're going to see all the frequent updates that give you cool new features. So, let's go back to our analogy. If the firmware is the brainstem, doing all the basic, life-sustaining work, then embedded software is the cerebrum. It handles the higher-level, conscious functions. It's what makes a smart lock a lock, or what makes a security camera a camera. It defines the device's whole reason for existing. Okay, so we've defined both of them. Now let's put them side by side to really hammer home the 4 key ways they're different. This table really clears things up. First, look at the level. Firmware is low level, talking right to the metal. Embedded software is high level. It's running on an OS or on the firmware itself. Next up, flexibility. Firmware is super rigid, designed for just those specific boot-up tasks. Embedded software, on the other hand, is way more flexible and handles all sorts of complex jobs. Then you've got storage. Firmware lives in permanent, non-volatile memory. Embedded software? It can be stored in all different kinds of memory. And finally, and this is a big one, updates. A failed firmware update can brick your device, literally turn it into an expensive paperweight. Yeah, not good. A software update is generally much safer and happens way more often. So, you see, it's not really a versus situation at all. They aren't rivals, they are totally inseparable partners. They work together in a layered system, and one simply cannot do its job without the other. This shows you exactly how they team up. It's called the software stack. You start at the bottom with the physical hardware. The firmware boots it up. Then, a lot of the time, an operating system sits on top of that. Often a real-time OS, or RTOS, which is just an OS that's great at handling tasks that have to happen at a very specific time. And then, right at the top, the embedded software runs, giving you the features you actually use. See? Each layer depends on the one right below it. If you only remember one thing from all of this, let it be this right here. Firmware brings the hardware to life. Embedded software tells that living hardware what to do with its life. Simple as that. Okay, so we get the difference. It's cool. But what are the real-world stakes? Why is this distinction so incredibly important in our day-to-day lives? Oh, it matters for everything. For security, the deepest, most dangerous bugs are often hidden away in the firmware. Fixing them means you need a full firmware update. For reliability, that risk of breaking a device during a firmware update is very real, which is why they are handled so carefully. But on the flip side, most new functionality, like that cool new voice command on your smart speaker, that arrives through an embedded software update. And the way we get all these updates today is through over-the-air, or OTA updates, which have to be smart enough to manage both of these layers safely. So, you see, understanding this stack isn't just for engineers. It actually determines how our devices stay secure, how they get new abilities, and how they stay reliable in a world where, let's face it, pretty much everything is connected to everything else. And that leaves us with a really interesting final question to chew on. As our devices get smarter and more complex, which do you think is ultimately more important? Is it the stable, unchanging foundation that the firmware provides? Or is it the flexible, always evolving purpose that the embedded software gives it? It's definitely something to think about.